So L'Hopital's rule is going to ride to our rescue. Let's see what says. It says that if we have AB, that's not a point, that's an interval, right? So this is an interval, AB, that contains the value C, and F and G are differentiable within that interval, except possibly at C, because C could be a weird point. If the limit of f of x divided by g of x as x approaches c produces that indeterminate form 0 over 0 or infinity over infinity. Very important to note. Those are the only two forms, and I highlighted it right here, that L'Hopital's rule can be used on directly. So if it's in one of those two forms, you can use L'Hopital's rule. If not, we'll talk about that in a minute. All right, but those are the type 1 indeterminate forms. Then it would be that the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. It's a little tricky. They're not quite equal. It's that they're equivalent. It's sort of the same thing that we were talking about a couple pages ago. So what we do is to denote this, over the equal sign, we put a little L apostrophe H. Some books actually just do an H. Or something like that. You have to notate that you're using L'Hopital's rule, and you will do the same when you do this in your work. So you'll notate that you're using L'Hopital's rule, because they're not actually equal. They're more equivalent than equal. So you'll write a little something over that equal sign to note that. And that's provided, of course, that the limit on the right exists or is infinite. If it's indeterminate, then you'll actually keep going and do more and more applications of L'Hopital's rule. We will often do several applications of L'Hopital's rule for the same problem. All right, so couple things. One, infinity over infinity can come in four possible forms. So infinity over infinity can be positive over positive, negative over positive, negative over negative, right? All four of those count as infinity over infinity. So the sign is not really relevant. And then we always denote the usage. Oh, I should have done it in a different color, I guess. Sorry about that. We always denote the usage. Here, I'll do it in orange right here, of L'Hopital's rule. It always has to be notated above the equal sign, always. And again, it's because they're not actually equal. It's that they're more like closely related and equivalent. So you always have to notate that. All right, we'll come back to the indeterminate forms, other indeterminate forms in a second. Let me just flip to the next page really quickly and kind of show you what we're talking about here. So we have a function f of x divided by g of x. And so what is the limit of f of x as x approaches c? And I actually have this on Desmos because it's a visualization of this. There we go. Right? So this is the visualization of L'Hopital's rule. It's kind of that same graph. So of f of x, as I approach that value c, so c is that constant in there within my interval. As I approach it, my y value is turning lower and lower and lower, and it's approaching 0, right? Now, actually at that value of c, right, there you go, see it? Right there. And then now g is also approaching 0. So the answer to the first two questions is 0, right? So f is approaching 0, right? No problem, right? F is coming up right in and going to 0. So that answer is 0. G is approaching 0, right? This function right here. That's also approaching 0. So no problem, right? But when I divide those two functions to make a new function, f of x divided by g of x, then what I want to do is I want to use my limit rules, right, that says, hey, you can just divide a limit by a limit, but that would get me 0 divided by 0, and that would be bad, right? 0 divided by 0 is indeterminate. Bummer. That's a real bummer, all right? So it's indeterminate. So what could I do? Well, what they're saying is you can approach the tangent line slopes, right? So let me go back to Desmos really quickly. And they're saying, well, okay, so those functions, when I did that, it's 0 over 0. But what if I took the slope of this line and the slope of this one, the slope of f, right, tangent to f at c, right? So that's f prime at c. And then I took g prime right here, well, the slope of this line, right? And I divide those, right? Then that would work. And I wrote that right here, right? L'Hopital's rule is saying that the ratio of those slopes of those lines is equivalent to the ratio of the functions themselves. See how the curve is coming through here? When you're doing the limit, what you're saying is, hey, take this curve and divide it by that curve and get me that value. Well, right up close to the value of C, there's no difference for all intents and purposes, right? They're not actually the same, but they're close to the line instead. Use the slope of the line and the slope of the line instead of the curve and the curve. So instead of using the blue curve and the green curve and taking the ratio of those two, take the ratio of their tangent line slopes, because that'll be similar, right? As I zoom in, you can see that the blue and the green are very, very similar to those lines, those tangent lines. Exactly. Right, that's what we're doing. So instead of using the curvy parts, because the curviness is getting us into trouble, let's try the lines instead. We can do that, right? So let me write that up. So I'm trying to remember what colors I had. I had red and orange, I think. So I have this one, that's the tangent line, right? Tangent to f of x at x equals c. Its slope is f prime of x, right? Actually, it'd be f prime of c because I'd be putting the values in, right? But it doesn't really matter. I'll just say that, right? And then this line right here, right, that's the tangent. Oop, tangent. There we go. To g of x at x equals c. And so what they're saying is, hey, if the curves are giving you difficulty, then go with the tangent lines and use their slopes. Right? That should work for you. So and of course, you're still taking a limit. So it's the limit as x goes to c of f prime of x divided by, oh, and this would be slope. Technically, the slope of any tangent line is equal to g prime of x, right? Any tangent line to g. So we'll take f prime of x divided by g prime of x. I don't want to say g prime of c because that value might not actually exist. So it's better to write the limit as x approaches c of the ratio of those derivatives. All right, so that's the plan. That's the idea. That's why it works, right? The curves are giving you issues, so use the tangent lines and grab their slopes and do the ratio of those instead, right? Because it should be similar to the ratio of the functions, right? Well, it should be equal for all intents and purposes. Again, that's why the all intents and purposes part is why I keep saying, and that's the L parentheses H, the L'Hopital's rule. They're not exactly the same, but they're equivalent. Now, there are other indeterminate forms besides 0 over 0 and infinity over infinity. There are these two types. So type 2 and type 3. And they're graded on level of difficulty. So type 2 is more difficult to work with than type 1, but not as difficult to work with as type 3. So you'll have to use algebra tricks. You're going to have to do work first in order to do these. And basically the trick you use for type 2 is not the same as the tricks you use for type 3. So you'll have to use all your algebra, trig, and pre-calc skills. And tricks to manipulate functions first, or to manipulate the functions and the values and the limits and all that good stuff. So you're gonna have to play around. But there's type 2 right here. Let's see, type 2. There they are. Infinity minus infinity and 0 times infinity. You don't know how much this is. Infinity minus infinity could be 0, could be infinity, could be 7. You have no idea. Right? They're just completely indeterminate. That's what I mean when I say indeterminate. Right? Indeterminate means we do not know what they are. They could be anything. All right. And then type 3 would be this type right here. 1 to the infinity, infinity to the 0, and 0 to the 0. Well, you think 1 to the infinity is 1, but it's not. It's not taking, this is not saying 1 times 1 times 1 times 1. What it's saying is you have a function that's approaching 1, but you're also going to infinity. So does it approach 1 fast enough that you can overtake the infinity or not? That's the question. So it's not really 1 to the infinity. It's a style. It's not really saying, hey, I'm going to take 1 to the infinity power, because 1 to the infinity power on its own is 1. But that's not really what this is. It's a function that's going to 1, but I'm also accumulating and going to infinity. Same thing with 0 to the 0, right? Is it approaching 0 fast enough, etc. So you're manipulating these limits in order to turn them into zero over zero or infinity over infinity. You're going to have to change any one of these 5 forms into one of these 2 forms, because these 2 forms are the forms you can actually use L'Hopital's rule with. All right, and then last but not least, just a reminder, these 3 types are not indeterminate. We actually know what these are. So we already mentioned this one. This was on a note on a previous page. If you have k divided by infinity, where k is a constant, that would be 0, right? So there's no question about it. It just is. So this is the limit as, I don't know, n goes to infinity of k over n is in fact 0. Period. No problem. Now, k over 0, well, that depends. It could be, here, let me just say, as n goes to infinity. Oh, no, shoot, as n goes to 0. I'm so sorry. Little typo. As n goes to 0 of k over n, the answer is it depends, right? But it's not indeterminate, right? So it could be infinity, minus infinity, or it could be plus or minus infinity. If you have a curve that's doing something like this, right, like that, that's possible. Or it could be doing something like this, that's possible. Or it could be something like this, right? It's going to be one of those 3, right? So if you take a number, a constant, and you divide it by n, it'll be one of those 3 types. Or, excuse me, you divide it by 0, excuse me. It'll be one of those 3 types. If you take a constant divided by infinity, it'll be 0, no matter what. So it's not indeterminate. You'd have to look at kind of, the function, look at the graph. We make those arguments in Calc 1, like the k was positive and you were approaching from the positive and blah, 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 right? And then last but not least, infinity plus infinity. If you take infinity and you add on more infinity, you know what you've got? You've got infinity, right? So this one's 0. This one's plus or minus infinity. It depends, right? This one, it doesn't depend, right? If I take negative infinity and I subtract off more infinity, I got negative infinity. 0 to the infinity power, that's 0. 0 to the negative infinity power, also 0. It's 0 to the 0 that can give you grief, right? And infinity to the 0. But 0 to the infinity power, 0 to the 10, 0 to the 12, no matter what, it's going to be 0. Okay? Now, I know you're eager for your first application and example problem of L'Hopital's rule actually getting put into action, but we'll have to wait for that for the next video.